Welcome to AP Environmental Science. In this video, we are going to talk about some of the ways that we can reduce the amount of air pollution that is being released from various sources. Some of these methods that we are going to discuss include regulatory practices, conservation practices, alternative fuels, vapor recovery, catalytic converters, wet and dry scrubbers, and electrostatic precipitators. We'll start here with the Clean Air Act, and this was passed in the year 1970, and over time it's been amended a few times. Now, the Clean Air Act regulates the emissions of air pollutants that affect human health and some of the air pollutants that affect the environment. However, the primary focus has always been to protect human health. Now, the way that this is done is by regulating vehicle emissions, and one of the things that they did was eliminate lead in gasoline, which lead is one of those 6 criteria air pollutants that we discussed earlier. Clean Air Act has also helped in reducing acid rain, and we'll talk more about that in a later video. But this set these acceptable pollution levels, so it set these limits on what was okay to emit into the atmosphere without significantly damaging those processes that are being done that are causing this pollution. This also has helped to phase out some stratospheric ozone depleting compounds, and we'll talk about that more later in the course. Some of the things that can be done to reduce emissions would be conservation. Now, conservation just means wise use of some kind of resource. So we could have wise use of energy resources. Remember, the production of electricity, particularly from burning fossil fuels, emits a lot of air pollution. So if we can use less electricity, that means that there is a less fuel being burned that is releasing that air pollution. We can also choose to use water-based paints and water-based cleaners. Those are going to emit less VOCs. Remember, VOCs are part of that equation that makes photochemical smog. We can also increase our fuel standards. So this means that we need to have cars that go a further distance on a single gallon of gasoline. That means that the amount of gasoline that you need to use in a given distance is going to be reduced, meaning that you're going to have less air pollution from going that distance. We can also have individual and community actions that help to reduce our emissions. These include composting and recycling, so using our waste products in regenerative manners. We can also carpool, so we have fewer vehicles on the road, especially if we are all going from the same origin to the same destination. It doesn't make sense to drive separately. Also, having these no idle zones. Remember, idling is when a car or vehicle is running, but it is not traveling any distance. So say you just need to quick run inside to grab something from, say, Walgreens, and you're with a friend, your friend should shut the car off while you run inside instead of sitting in there with the car running. Again, we can use alternative fuels. Alternative fuels reduce our reliance on fossil fuels and are using that modern carbon. So some of these renewable and alternative fuels rely on biofuels and ethanol, which are using that carbon that was stored during photosynthesis in recent time instead of things like fossil fuels that rely on that carbon that was stored in ancient times. The U.S. also has the National Renewable Fuel Program, which is designed to increase the amount of renewable fuels that are being used and blended into gasoline. Some of these possible new renewable fuels include algae, crop residues, using municipal solid waste, woody biomass, corn kernel cellulose, energy crops such as switchgrass, using those oils, fats, and greases, those as our sources to blend into the gasoline to reduce the amount of fossil carbon that's being used. And thus we are reducing our impact on the atmosphere. We can also use what's called a vapor recovery nozzle when we are fueling up our cars with gasoline. A vapor recovery nozzle helps to capture any of those vapors from your gas tank that would escape into the atmosphere while you have the gas cap off and are trying to put new gasoline into your car. So this vapor recovery system captures those vapors and sends them back into that underground storage tank. Now, the vapor recovery nozzles are not widespread across the entire United States. You see them particularly in the West Coast in Southern California, where we see a lot of that smog formation. Again, because gasoline is a volatile organic hydrocarbon, it evaporates at room temperature, and that helps to contribute towards smog and other atmospheric pollution. Catalytic converters can also be used in the exhaust system of a vehicle to reduce those nitrogen oxides that are emitted from that car. And those nitrogen oxides lead to photochemical smog formation. So if we can reduce those, we can reduce the amount of smog, which means we are improving our air quality. Now, what happens in a catalytic converter, and I have this diagram on the bottom, we have our exhaust gas comes in that contains that nitrogen oxides. Inside of the catalytic converter, there are precious metals that lead to some redox reactions that take place. You do not need to know the actual chemistry that's happening in there, but that nitrogen oxide is split into oxygen and nitrogen, and those are not harmful to the atmosphere. Remember, the majority of our atmosphere is made of nitrogen gas. The carbon monoxide that goes into, or that is coming out of the exhaust pipe, that is reacting again with the catalyst inside of that catalytic converter, and that is producing carbon dioxide and water. Now, carbon dioxide is a greenhouse gas. However, it does not lead to that photochemical smog formation, and the whole goal of using this catalytic converter is to reduce those nitrogen oxides. When we look at an industrial scale of air pollution, we can use these things called scrubbers to clean that exhaust gas that is going up the large smokestacks from that industry. So we can have both wet and dry scrubbers. This diagram here is looking at a wet scrubber. A wet scrubber uses water or some type of liquid to create a mist that this exhaust has to go through. Now that mist binds with any particulates in that exhaust and causes them to be heavier than that airstream, and they will fall to the bottom and be collected where it can be treated then, and that sludge can then be sent to a land disposal, and it's not going into the atmosphere. We can also use a sulfur oxide control by using a little bit of limestone in there, and that helps to reduce those sulfur dioxides, which can lead to acid rain. Now, the dry scrubber is similar to a wet scrubber. However, instead of using a liquid mist, we are using dry particles to capture and change those particulate pollutants, again causing them to fall to the bottom and be collected. Now, dry scrubbers are not as effective as wet scrubbers. However, they still are improving the air quality, and they are reducing the amount of pollution that is coming out of the smokestack. Finally, we have electrostatic precipitators. Now, I think these are really cool because they are just using these electrical charges to attract these pollutants to metal plates. And these metal plates are over a hopper. And once that metal plate is full of these particulates, that metal plate will vibrate a little bit. The particles will fall down into the hopper and be collected. Now, oftentimes, electrostatic precipitators are the first step that is used before that gas then goes to a scrubber to remove a little bit more of the particulate matter and pollution. Now, in summary, you should be able to explain how air pollutants can be reduced at the source. Some of the topics we discussed were the Clean Air Act and how conservation can reduce air pollution along with alternative fuels, vapor recovery nozzles, wet and dry scrubbers, catalytic converters, and electrostatic precipitators. Some things to keep in mind here is that these large scrubbers and electrostatic precipitators are expensive to install. So companies would not put in the extra money to put these in if there wasn't already some kind of regulation telling them that they have to do it and fining them for not doing it. So it really comes down to the economics of whether or not it is financially beneficial for that company to either pay the fine or install this pollution control device. That is why the Clean Air Act is so incredibly important. Again, this was a lot of information. Please leave me your questions here at the end, and I hope that as you watch this video, or even if you rewatch this video, you are able to learn something.